Hello, this is Dr. Paul Cottrell, and I'm going to be doing part 2 for the pseudouridine. As I mentioned before in part 1, the pseudouridine can have different forms. And there are endogenous pseudouridine that's used to improve the structural integrity of certain molecules, such as tRNA, messenger RNA, ribosomal RNA, small nuclear RNA, and these pseudouridines have a structure that's like this. Oh, sorry. That's pseudouridine. And the messenger RNA platform that Cottrell and Weissman created is changing this section here and turning that into something like this. You have the same backbone, right? This structure here, instead of having a hydrogen attached to the nitrogen, it's actually a carbon with 3 hydrogens. So it's methylated. This is what we would call the messenger RNA platform by Cottrell and Weissman. This is the endogenous pseudouridine that I'll do another video on this one a little bit more in detail, or maybe at the end of this video, at the tail end of this video. Okay, so now what we want to talk about, so that was just a brief summary of what I did on part 1. Now what we want to do is we want to talk about how does this pseudouridine get created from uridine. Okay, so first the body will use uridine, and then there's a post processing of these, either the transfer RNA, the tRNA, the messenger RNA, the ribosomal RNA, or the small nuclear RNA. Okay, so it starts with uridine. Okay, so the molecule that it's going to start with is this one. Okay, it starts with uridine. And it looks very similar to pseudouridine, except it has a double bond right here, and this part of it gets kind of rotated. Gets rotated, and ends up being this. Okay, you can see, so this is pseudouridine. Okay, this is the pseudouridine, and this right here is the uridine. Okay, and this is going to move towards, get processed and become this pseudouridine. Uridine to pseudouridine. Okay. I think I didn't put the double bond on this. Yeah, I did put the double bond. Okay. So with that said, okay, so this is the pseudouridine. Okay. Now there is a enzyme that makes this process happen. Okay, this is called a pseudouridine synthase protein. Okay, this comes in and actually makes uridine into pseudouridine. Now, what's really happening here is that in the RNA, either transfer RNA, messenger RNA, whatever, you have the AT. I'm sorry, I don't have no T. You don't have any T's. So A, C, G, and instead of a T, we have a U. Okay, the uridine. Okay, and then maybe an A, a C, a C, a G. Okay, then once this is constructed, this is the RNA. Could be transfer RNA, could be ribosomal RNA, it doesn't matter. Okay, once this is created, it'll go through another process to make this U into a pseudouridine, which we will symbolize as this. So we have this, which is this molecule, and we have this, which is this molecule. And the main difference is this rotation, right? This rotation that takes place. And it uses this enzyme, the pseudouridine synthase protein, okay? And then this allows for that structural integrity that I talked about in part 1. Now, what are some of the different enzymes or types? Okay, so there's like different families, I guess is the term to use. Okay, so there's going to be different types of the pseudouridine synthase proteins, okay? And these all work post-transcription, like I said in the previous slide, post-transcription. So they work at post-transcription. So the RNA is created first, and then the modification of the uridine. Now, there are different pseudo synthases, okay? And it looks like there's about 5 of them, 5 different types. So let's count them. All right. So there's something called TRUA, TRUB, TRUD, RLUA, and RSUA. Okay. And there are different pseudouridine synthases. Okay, so we're going to call this PUS. Okay, pseudouridine synthase. Okay, these can be broken down into like a subset of PUSs. Okay, and there's a PUS 1, PUS 2, PUS 3. This one has a PUS 4. This has a PUS 7. This has PUS 5, 6, and 8, 9. And not much is known about this one, but it looks like what the research that I brought up, this one looks like it's tied to bacteria, and it's going dealing with the ribosomal RNA. And in this case, it's 16S ribosomal RNA. But this is, I don't think this has been researched enough. Okay. All right, now let's break down the individual ones. Okay, let's start with the TRUA. TRUA. Okay. So this involves the transfer RNA, the small nuclear RNA, and the messenger RNA. Now, PUS1 modifies tRNA. Remember, this is all post-translation, post-transcription of the messenger RNA. So you have the tRNA with uridine, and then PUS1 will turn it with pseudouridine in certain locations. Now, in the small RNA, remember I didn't know specifically where they were. This location for this translation between this post-transcription, changing the uridine to pseudouridine, is in location 44. And location 28. Okay, now PUS2. This is located in the mitochondria. And it's modifying mitochondrial transfer RNA. Now, for the ones that don't know, in your cell, you have your own DNA, right? But you also have mitochondria, and mitochondria has their DNA. So they will also need their own transfer RNA. Okay, so this is mitochondrial transfer RNA. And this will modify locations U27 and U28 on the mitochondrial DNA to turn uridine into pseudouridine. Okay, now PS3. It's similar to PS1, and it's dealing with transfer RNA at the U38 to U39 position. And this is cytoplasm and in the mitochondria. Okay. Now, this is also targeting not just the tRNA, but the messenger RNA as well. And what is interesting is that there's another type which I didn't cover, NcRNA, which is non-coded or coding, non-coding. All right, now next is TRUB. Now, TRUB is dealing with the PUS4, and this is in the nucleus and mitochondria. Okay, and it's tied to U55 location for the transfer RNA. So again, remember the transfer RNA looks something like this, right? Right, and there's like bonding here, these locations, and the hairpins, and different location numbers will be where this PUS4 will come in and modify. In this case, it's modifying the U55 position. and it's going into the T loop. There's a D, a T, I think the T, and I have to bring a chart up. I forgot. I forgot which one is T. I think T is here. Transfer RNA. No, okay. The T is here. The T is here. That's the T loop. This is the D loop. This is the anticodon. Loop. Okay. And actually, I didn't draw it, but there's actually a little appendage here, which is called the variable loop. Okay. All right, so this enzyme is working in this location. Okay, now TRUD. Now remember, these are all just turning uridine into pseudouridine post transcription. This is dealing with PUS7, and it's the U2 SN RNA. Okay, there's different types of SN RNA. In this case, it's the U2 version, and it's at the position 35, U35 position, that it makes the modification into pseudo 35. Now, what is interesting is that they found that for messenger RNA, when you're using this PUS7, you actually get more heat stability. So it's called heat shock. It increases the heat shock. Okay. By changing some of the messenger RNA to go messenger RNA with the uridine, and then messenger RNA in some locations with the pseudouridine. This will increase its heat stability. When it's moving from, so what happens is that there's this heat shock, right? And that you have this messenger RNA being made in this nucleus, right? Okay, this is the nucleus, and you have this messenger RNA being made in the nucleus, and it's being transported out. When it's getting transported out, there's a heat shock. Okay, the heat shock stability is from this. This is where there's these heat shock proteins that are in the cytoplasm. I remember talking about heat shock. What was it? It was in 2020. Some of the chaperone proteins. I don't remember which. Okay, now let's talk about RLUA family. Now this one has different types, 5, 6, 8, and 9. Very similar to the idea that true A has, 1, 2, 3, 3 types. So RLU has 1, 2, 3, 4 types, okay? Now for the PUS5, it's similar to PUS2, which I talked about in true A. Now what this does is it's modifying U2819 in the mitochondrial ribosomal RNA. Okay. Now there's, like I said, there's different types of ribosomal proteins, right? So in this case, we have a what is called a 21S ribosomal RNA in our mitochondria. Okay, so it's modifying this position. It's suspected that PUS5 also modifies RNA, but more data need more data for that. Okay. PUS6 modifies the U31 position in the cytoplasm and the mitochondria transfer RNA. And it also modifies the RNA, messenger RNA, I suspect in the cytoplasm. Okay. Now, PUS8 also deals with transfer RNA at the U32 position. Seems to be necessary in yeast. And it's suspected to be part of it, help with riboflavin synthase. Okay. PUS9, remember this is all under the RLUA family. So PS9 looks like it works with PS8. Or not works with, I should say. Seems to be works in the same location. or mitochondrial RNA, a mitochondrial transfer RNA. And this can also modify RNA, messenger RNA. Okay. So again, let me just reverberate on what I said here in this part of the video. Okay, the whole point of this video is to add to what I did previously. The first video was talking about the structure and the overall concept on how a uridine needs to be modified into pseudouridine to increase the structural integrity of either a transfer RNA, a messenger RNA, a ribosomal RNA, a small nuclear RNA, and in some cases, non-coding RNA. And that structure it turns into this structure here, okay? This is different than what Cottrell and Weissman did with their messenger RNA platform because they added a methyl group. All right. Now, so the uridine gets moved towards pseudouridine post-transcription, meaning your RNA is created with uridine, right? And uses pseudouridine synthase to modify that uridine in certain positions. Let's say the U35 position or whatever, okay? And it'll make this structure, okay? And the only thing it's really doing is it's just rotating it. It's really rotating it. And when you're rotating it, you kind of, and bind it together again, you can kind of see that this thing kind of rotates around this axis, and it just makes this form. That's all this pseudouridine synthase protein does. But different types, like PUS5, will look for different shapes within the RNA structure to bind to change specific locations. So this is, these are like, these, change a certain region, a certain location, like, only U35 or only, U57 or only, or it may be a cluster. Maybe it's U58 location all the way to 67 or whatever, right? So these are specific, right, locations along this structure of this RNA that's happening, okay? It's looking for a certain structure, and then it'll change that. Let's say it's this region right here. It would, that enzyme would come in, right? Catch that structure, change that to a pseudouridine. And then this right here would break off. And then now you have the pseudouridine. So these PUS whatever will focus on certain topology within certain sequence or certain typology on the RNA. And there are different families. Okay, now here I'm mentioning just in generic, all right, so we have pseudouridine synthase proteins. They're post-transcription. Okay, that means that the RNA is created with the uridine first, and then the synthase is used, this PUS, and then it'll turn into some regions pseudouridine. And there are 5 different families: the TRA, the TRB, I'm sorry, TRUA, TRUB, TRUD, RLUA, and RSUA. RSUA, there doesn't seem to be a lot of data on that. That seems to be tied to bacteria. The TRUA has POS 1, 2, and 3. The TRUB has POS 4. TRUD has PUS 7, and in the RLUA family, it's PUS 5, 6, 8, 9. Okay. Now, in the TRUA family, this modifies transfer RNA, small nuclear RNA, and messenger RNA using the POS 1, POS 2, and 3, and I think it's 4. All right, so PUS 1 does the transfer RNA and also the small nuclear RNA. For the small nuclear RNA, it's specific for U44 and U28. Now, some of these PUS 1s may not be as specific compared to others. Some PUS could be more specific to a location, more affinity to a location, and some may be less specific. Okay, so PUS2 deals with the mitochondrial transfer RNA, and like I mentioned before, your mitochondria has its own code, and it needs its own ribosome, and it needs its own transfer RNA. Now, that location for PUS2 is U27, U28. PUS3 is very similar to PUS1. It's a transfer RNA. It's specific to the 38 position and a 39 position on the transfer RNA. It works in the cytoplasm and in the mitochondria. And it involves the transfer RNA, the messenger RNA, and the non-coded RNA. So here's a perfect example where you can have PUS3 that's specific to tRNA for mitochondrial or cytoplasmic. All right, only for position U38 and U39. But PUS3 can also be nonspecific to regions for the RNA and nonspecific to the non-coded. So it's a little bit more looser. It's like almost like a key. If you kind of imagine a key, where a key is going into a lock, and if it's really perfect fit, it feels different when you're turning the key versus a key that's slightly off. It'll still work, but it's just there's a little bit of loose play. This is PUS to the transfer RNA. It's very, very specific, very tight. But PUS3 on, let's say, messenger RNA or non-coded RNA is a little bit looser. So it's non-specific. TRUB deals with PUS4, and that's in the nucleus and in the mitochondria, dealing with the transfer RNA at the U55 position, and it deals with the T loop. Again, what I said before, you got a transfer RNA. This is where the variable loop is, the anticodon. All right, this is where the amino acid is being held. All right, so here's the variable loop. This is the T loop. This is the D loop, and this is the anticodon loop. Okay. Now, TRUD deals with PUS7, and there's different types of small nuclear RNA. In this case, it's the U2 version, and this one is U35 position. So it's modifying the U35 position into a pseudouridine. It also works with the messenger RNA, and it's helping with this transfer from nucleus to cytoplasm and this heat shock that takes place. Okay, so now RLUA is PUS5, 6, 8, and 9. PUS5 is very similar to PUS2 that's in TRUA. And it is modifying the mitochondrial ribosomal RNA specific 21S at the 2819 position. And it also seems to be working on the RNA as well. Now, again, keep in mind, when this pseudouridine is being converted to pseudouridine post-transcription, this is to stabilize the molecule. All right, now the PUS6 is dealing with changing the U31 position in the cytoplasm and in the mitochondrial transfer RNA. Also deals with messenger RNA in the cytoplasm. Okay. And then RLUA has PUS8, and this deals with the transfer RNA at the U32 position and seems to be important in riboflavin synthesis. I spelled this wrong. Riboflavin. Okay. PUS9 works similar to PS8, and it's dealing with the mitochondrial transfer RNA and the messenger RNA. So that is the presentation, part 2. And then part 3, I'm going to go over the actual, go over the differences between what I'll call endogenous pseudouridine and the Cottrell and Weissman pseudouridine that uses methylation. And then in that same video, I'll bring up about cancers and how pseudouridine is actually upregulated in cancers. These PUSs are upregulated, and they create more stability, so it prevents the protein machinery from turning off. So you have genomic instability and fusion proteins that are taking place in the cancer, but it's upregulating these PUSs that are leading to more pseudouridine structural integrity for the transfer RNAs, the messenger RNAs, the ribosomal RNAs, which leads to the production of proteins that the cancer cell needs, is my point here. Now, let me Yeah, sharing on the iPad is not as easy as the laptop, for sure. I like the functionality sometimes on the laptop more than or it's the functionality on the iPad more than the laptop, except with the sharing function. But because I use the whiteboard with the Apple Pen, it's just easier to do it on the iPad versus the laptop. Now, um, okay, so that video I just did, part 2, is explaining the details of the actual enzyme that transfers the uridine into pseudouridine. And it's different than the methylation version that's in the Weissman Caraco messenger RNA platform. So please subscribe to all my channels. I have 3 channels on YouTube. I have a Brighteon, Bitchute, and Rumble channel. All the descriptions are in this video and all my videos. So just click the link in the description and subscribe to all those channels. You can help support my work by donating on Stripe or PayPal. Just click the buttons at the bottom of my homepage. My website is the-studio-reykjavik.com. And you can help support my news coverage that way. You can also donate on Buy Me a Coffee. The link is in the description of this video. You can also go to the store. And by going to the store, you can purchase the products that I offer. I have nano silver products, C60 products, supplements from Boomer, and all natural deodorants from Rainbow Herbals. So the nano silver products that I offer are the toothpaste. So this is a great toothpaste. It has no fluoride in it. It uses the structural nanosilver to neutralize the pathogens. By doing that, it will reduce the plaque. It'll improve your cardiovascular health. It'll whiten your teeth and reduce that gum inflammation, which is key. I take Health Max 35 every day. I take a teaspoon of it every day. If I'm not feeling well, I take a tablespoon. If I'm really not feeling well, and it's not going away, then I take two tablespoons of it throughout the day, maybe one in the morning, one at night. But I take a teaspoon of this every day just to neutralize the pathogens. What I do is I gargle with it, swish it in my mouth for about 60 seconds, gargle for another 60 seconds, and then just swallow it. And what's happening is that you're neutralizing the pathogens in your mouth, deeper in your throat, and down your esophagus. Now, I also use the silver gel. Now, you can use the silver gel 4 ounce, or you can use this silver gel extra strength. Now, these silver gels, what you do is you put it on your hands, right, and you will be able to neutralize pathogens for 5 hours. It stays on your hands activated for 5 hours. So you can put it around your lips, around your mouth, around your nostrils, around your nose, around your ears, right? Lightly coat your ear canal, and you're neutralizing pathogens that way. In addition, you can use this as a skincare product and put it on your skin and leave it on there overnight, and you'll start to see an improvement on your skin. I have silver, structural nano silver soaps of different varieties, charcoal tea tree, peppermint, lavender, oatmeal, lemongrass. I also have lozenges. I have in stock right now the sweet menthol. I'll be getting in stock pretty soon here, the green apple. I have 2 different types of probiotic. This type of probiotic here is from Amio, and that probiotic is in a capsule form. I also have a 30 ppm nano silver solution from Amio that you can purchase. which works just as well as the Max 35. Now, I have this multivitamin also from Amio, great product. And then I have these applicators where you have a dropper or a nasal spray and a regular spray bottle. Now, so you would put the nano silver. You can put the nano silver in these bottles, the liquid nano silver, and spray it, or nasal spray, or dropper. Okay, now the C60, very strong anti-aging product. I have back in stock the avocado 2-ounce. So I have the avocado. It's in avocado and in coconut. C60 is a very it's a buckyball. It has 60 carbons, and what it's doing is it's soaking up those reactive oxygen species that are in the cell, creating cellular stress. And when you soak those up, then you are giving the cell less oxidative stress, so it can heal better, and it also improves the mitochondrial health. So when you're improving the mitochondrial health, then you're going to be able to create the ATP that you need. So I sell it in 2-ounce, 4-ounce, and 8-ounce. So please try that product. It's a great product for being a strong antioxidant. Now, Boomer products. I have a plethora of supplements. So I have the D3, which is great for gene transcription. It helps with calcium absorption. It also helps with apoptosis of cells. And it's been shown to help with cardiovascular, especially if you couple it with K2, MK7, ashwagandha, and turmeric, and the C60 or resveratrol, and that will help reduce the plaque buildup. So D3 is a very important supplement to take. Vitamin C. Everyone needs the vitamin C, especially for your immune system, but not just that, for your dermis. Your skin for proper skin health, you need vitamin C, and you need to drink about 64 ounces of purified water, filtered water. How I do my filtration is I have a 5 filtration system through Zero Water. But filtered water, 64 ounces, taking vitamin C and collagen are really important to build up your skin. Omega-3, very important for your cardiovascular health. Ashwagandha, control those blood glucose levels in your adrenal system. Now, Goodnight formula uses melatonin and tryptophan to get you to get into that REM sleep that you need. So proper sleep has been known to be able to help with the healing of the body. Your cells do not heal as much if you're getting improper sleep. If you're sleep deprived, your cells, your body is not healing to the best of its ability. And what's even interesting is that people that have chronic insomnia have a tendency to actually have more protein buildup in their cerebral spinal fluid. What happens is that when you sleep, your system is kind of flushing out. But when you're not sleeping, if you're sleep deprived, your CSF is not flushing out as properly as it should be. The probiotic, this is the powdered form instead of the capsule form. I use this product. I put it in my hummus every day, or you can put it in a smoothie. It's a great product. It's important to have good gut biome. So taking the probiotics I offer as part of your protocol for improving your well-being is important. Resveratrol, strong antioxidant, helps with apoptosis of cells, get rid of those, get rid of the senescent cells. Senescent cells basically just stay there. They're not dividing anymore. And you need to get rid of them. And when you get rid of them, what it does is it starts to activate the basal layer of some of the adult stem cells, and it starts creating new ones, new cells. And this is how people that go through an anti-aging protocol have a tendency to look younger, because they're reducing the reactive oxygen species and they're getting rid of the Synthase cells. And when you get rid of the Synthase cells, on average, your telomere lengths will be longer in that tissue because the activation of the basal layer of the adult stem cells. The vitamin B complex, very important. You know, these are cofactors for many metabolic processes. So to prevent the anemias, let's say macrocytic anemia, you need B12. To prevent problems with the electron transporting chain, you need B1, B2, B3, right? B5, right? So you know, if you don't take, you know, your B complex vitamins, your metabolic processes will slow down, your energy will slow down, and potentially have anemia. Turmeric, this is great for bringing down that inflammation. Like I've been saying, there's 3 pillars to the protocol, 3 main pillars, and then you add stuff to it. Neutralize pathogens with the structural nanosilver, reduce reduce the reactive oxygen species with the strong antioxidants like C60 and resveratrol, and reduce that inflammation by using the ashwagandha to control the blood glucose levels, and use the turmeric to bring down the pro-inflammatory cytokines. The magnesium and zinc as a supplement, it's important to take extra zinc if you're sick. That helps with clearing a cold. Lignans, very important for your hormonal health, and it'll boost your immune system. What I do is I take this lignans with the probiotic and put it in my hummus because it's in a powdered form. Collagen, very important to help with, you know, joint injuries, trying to rebuild up some of that cartilage and tendon and ligaments. It takes a while. It takes a little bit of therapy. If you have some sort of joint problem, especially if, you know, it's some sort of sports injury or, you know, overusage, takes a while. But taking more D3 with collagen and doing very light resistance training on the injured or the problematic joint, you know, because of the arthritis, over time you would actually reduce the arthritis. It takes about 9 months, but light resistance training, higher doses of D3, taking calcium, taking the collagen, and doing, you know, moderate, very moderate, light resistance training on the problematic joint will help. It takes about 9 months to heal, but taking collagen on a regular basis with the vitamin C, drinking the 64 ounces of water, using the structural nanosilver gel on your skin, and what you'll notice is that your skin will be improving. It's a skincare protocol. Digestive enzymes, really important. If you're working out all the time and you need to recover, you know, fuel your body, you need to break down those carbohydrates, those lipids and the proteins that you consume, and put less stress on your pancreas. So taking the digestive enzyme complex as a recovery or a fueling method, if you're really into working out, lifting weights, running marathons, training for triathlons, whatever. But also when you get older, you're maybe not as active, you know, our pancreas starts to wear down. And to help with reducing that stress load on the pancreas, taking a digestive enzyme complex will help with breaking down those proteins, lipids, and carbohydrates. Clarity factor, extremely important. The reason being is a lot of people, because of their diet and lack of exercise, so the poor diet and lack of exercise, they get brain fog, especially for individuals that are drinking fluorinated water or too much sugar. If they have too much sugar in their diet, so that, you know, they get this lack of clarity. So you take this product and you will actually start to feel, you'll have more energy and you're going to actually have more clarity. But you don't just take this product. You need to really sit down and change your lifestyle habits. If you start drinking water that is filtered, so you're getting rid of the fluoride. I use zero water filtration system, but you drink that water on a regular basis, right? Your filtered water. You get moderate exercise, and try to get that proper sleep. If you're having problems with the proper sleep, get the good night formula, but use the clarity factor, because what happens is that these neurons are now going to be firing more, and when you're firing more, you're going to be able to solidify memories better, and you're going to have more energy, right? And remember what I said about the C60 and the resveratrol. When you reduce the reactive oxygen species and you're increasing the health of the mitochondria, you're going to have more ATP, and your neurons need ATP to fire out those neurotransmitters. So clarity factor is going to actually help with mental acuity over time. So it's a very important. If you want to maintain mental health, mental conductivity, memory, and ability to just think clearly, your clarity factor is an important supplement. Because what happens is that when you're not using those neurons, the dendrites of those neurons start to recede. It's called depression, actually. But not the psychiatric version of depression, but just the neurological definition of the dendrites receding. So when you have these dendrites that are receding, then you aren't going to be able to solidify memories as well. You're going to think slower, and you're going to, that's where the aging starts to come in. But if you get those things firing, the dendrites will start to move and start to connect more and reduce that recession that's taking place, the receding of the dendrites, and actually they will proceed, they will move and get more conductivity. So it's really important to think in those terms as we get older. All natural deodorants and an Even Better bar. The Even Better bar is a great product. It will, if you have a sore muscle, let's say from a workout or whatever, or you pull your back or whatever, use that on the muscle and you'll notice pain relief. In addition, if you have cuts, scrapes, or bruises, minor burns, using this product will help heal those. Insect bites, reduce the itching. Use the Even Better bar. Maybe some problematic acne, or dermatitis type stuff. Use the Even Better bar. Now, this Even Better bar can also be used as a skincare product, so to smooth your skin. So the ingredients on here are coming from essential oils from the Himalayas. So it's very, very high quality. These bars here, the deodorants and the Even Better bar, are coming. They have extremely high quality ingredients. So when you use it, you'll start to realize, oh, now I know why this bar is so good, and it is a little expensive, but the quality of the ingredients are top notch here. All right, so please try the Even Better bar. If you have purchased one and you're running low, please purchase another one. In addition, I also have the citrus deodorant and the peppermint lavender tea tree deodorant. Great product, also made out of essential oils from the Himalayas, and check those out. Very, very good product. They don't have any aluminum in it, so natural. A lot of it is certified organic material, and try them out, and you'll be amazed on how great the product is. In addition, I have different types of curated anti-aging boxes for people that are just starting out and they don't know what to buy. So, for example, for a beginner that wants to start an anti-aging protocol, get this anti-aging beginners box. You get a max 35, you get a C60 4-ounce, and you get D3. So you're neutralizing pathogens with the structural nanosilver, you're reducing the reactive oxygen species, and you're getting that supplementation from D3 for helping with gene expression and calcium absorption and apoptosis of cells when they need to be need to go down the apoptosis pathway. So another great product, like I said before, skincare product. Here, silver gel 4-ounce, the vitamin C and the collagen. Now there's also an advanced box which also has the resveratrol and C60. So when you drink that 64 ounces of water, purified water, filtered water, then you'll start to notice when you're doing this on a daily basis, you'll start to notice that your skin is actually getting healthier. So those are the products that I offer on the store. And, please, try out those products, take a look at them. The toothpaste is a great product. It is way better than Alex Jones toothpaste. And by purchasing the products on my store, and following the protocol that I have been doing for a long time, basically antioxidants, and then over the decades, there have been improvements in supplementation, and I've been adding to my protocol due to those improvements in the health supplementation market. But I'm a firm believer: neutralize pathogens, reduce pro-inflammatory cytokines, and bring down the reactive oxygen species with strong antioxidants, and you're going to fare very well with your health, and you're going to start to improve. You're going to start seeing that your body is aging slower. You're taking the probiotics, and you're filtering those waters, and you're getting the proper sleep, moderate exercise. Challenge your mind by reading, by talking to people, thinking positive. Then you're going to start to see that your body is aging slower, and that your quality of life is getting better. So please take my advice and follow the advice that I have. Please go to my store, the-studio-reykjavik.com, to purchase the products that I offer, or to donate to help support my news coverage. With that said, thank you for listening to this part 2 of the pseudouridine synthesis, and how it changes the structural integrity of the RNA. In part 3, I will talk about the RNA platform, the messenger RNA platform from Weissman and Cottrell, and how the methylation of pseudouridine is different, and why they did what they did for the messenger RNA platform, and how an upregulation of pseudouridine in certain types of cancers have been seen, and the reasons for that. So stay tuned for part 3. Thank you for listening. Thank you for supporting my work. Please subscribe to all my channels. Use the links in this video and all my videos to be able to get to the store, to get to my channels, and make sure you subscribe. Thank you for listening, and have a nice day.